In this video, let's talk about why JNI calls sometimes crash your program, and what's really happening inside the JVM when that occurs. When Java calls a native method, the JVM doesn't run any Java bytecode. Instead, it looks up the function pointer from the class's method table, sets up a call frame, and jumps directly into your C or C++ function. At that moment, the JVM assumes your native code will play by the rules. But once control is passed into native code, the JVM can no longer protect you. A single mistake in your C function can take down the entire JVM process. One common cause of JNI crashes is a mismatch in method signatures. For example, if your Java code declares a method that returns a long, but your C code implements it as an int, the JVM will push arguments expecting one layout, while your function expects another. This corrupts the stack and usually leads to an immediate segmentation fault. Another frequent source of crashes is misuse of object references. JNI objects like gstring, jobject, or jRay are opaque handles managed by the JVM. If you keep a local reference past its lifetime or treat a jobject as a raw C pointer, the JVM may crash when it tries to dereference that handle. Crashes also happen when you forget to release arrays or strings. For instance, if you call getinterrelments or getStringGutVars, the JVM may pin or copy memory for you. If you don't release it properly, you either leak memory or hold on to stale pointers. Writing past the end of these buffers directly corrupts JVM memory. Threading mistakes are another pitfall. If you create your own C thread and try to call back into Java without first attaching that thread to the JVM, the JNI env pointer you use will be invalid and any JNI call can trigger a crash. Sometimes the issue is as simple as using the wrong library built, a 32-bit library on a 64-bit JVM, or using the wrong calling convention. Means arguments don't line up and the JVM crashes immediately. And finally, direct memory corruption in your native code, like writing past the end of a buffer, will overwrite JVM structures. Since the JVM and your native code share the same process, this kills the whole virtual machine. So what's wrong internally? The answer is that JNI is not memory safe. The JVM trusts your native code completely. If you play by the JNI rules, everything works fine. But if you misuse references, mismatch signatures, or corrupt memory, the JVM cannot recover, and it simply crashes. To debug these issues, you can run with -Xcheck::JNI to catch common mistakes. Check the HS error log file to see which frame caused the crash, and attach a debugger like GDB or Visual Studio. Always compile your native code with debugging symbols to make tracing easier. In short, JNI crashes because the JVM jumps into native code without any sandboxing. Your native code has full power and full responsibility.